Hello everyone. In this lesson, we'll focus on mutually exclusive and exhaustive events. Our key inquiry question: how to identify mutually exclusive events and exhaustive events, how to calculate the missing probability and represent them either as a fraction, decimal, or percentage. Mutually exclusive events, what are they? Mutually exclusive events are things that can't happen at the same time. For example, you can't run backwards and forwards at the same time. Exhaustive events are events if all possible outcomes have been included. The instructional videos are on slide 2 for your reference. Please play them, both of them, to understand the concept of probability and mutually exclusive events. Slide 3 contains the 5 for 5 starter questions, and the answers are given in slide 4. Now, the tasks are well laid out. It's important you go through the slides and start completing the task on a piece of paper or in your exercise book. I would like to go through a couple of examples in the video to get you started. First, an introduction to probability. To calculate probability when all possible outcomes are equally likely, we can use the formula. Probability, which is given as P of X, is the number of ways an outcome can happen divided by total number of possible outcomes. For example, calculate the probability of rolling an odd number on a fair six-sided die. It's important to use the correct notation rather than writing probability of obtaining odd number. We have P, which means probability of odd number, which would be, there are three numbers in the die which are odd: 1, 3, and 5, and there are 6 possible outcomes, which is 3 over 6, or can be further simplified as half by dividing it by 3. Events not happening. A dash means A does not happen. For example, probability of getting A dash is 1 take away probability of A, because the total probability is always 1. A and B are mutually exclusive events, which means A and B cannot happen at the same time. Probability of getting an A is 0.3 and probability of B is 0.2. What's probability of A or B? In this case, notice we've added 0.3 plus 0.2, which provides us 0.5. As they are mutually exclusive, they don't happen at the same time. So for this, we'll be adding them together to calculate probability of A or B. Probability of A dash is 0.7, which is 1 take away 0.3. Probability of B dash is 1 take away probability of B, which is 0.2, gives us 0.8. Now let's look at example 3. E, F, and G are mutually exclusive. Probability of getting E or F is 0.6, F or G is 0.7, and probability of E or F or G is 1. How do we calculate probability of F, E, and G? We know probability of E or F or G is 1, and we know probability of E or F is 0.6. So probability of E or F is 0.6. Subtracting them would cancel out E or F, will give you probability of G is 0.4 because 1 take away 0.6, which provides you 0.4. Once you calculate probability of G, you can substitute in it. Here it says probability of F or G, which would be probability of F or G plus probability of G is equal to 0.7. We know probability of G is 0.4, so I could erase this and replace it by 0.4, which means probability of F would be 0.3. Once we calculate that, we can easily calculate probability of E is 0.3 using either the first factor or the last one. Please answer the question on slide 30 once on a sheet of paper or in your exercise book. Once completed, you can either click and delete the question mark or drag it aside to reveal the answer. Once completed, you need to open the probability introduction worksheet and complete all the questions. Make sure you type in the working out clearly. As usual, please let me know if you have any questions.